In this next video, we're going to go back to objective 2. So we are trying to build how to graph parabolas. And when we're graphing parabolas, we're going to be looking at an A term, we're going to be looking at an H term, and we're going to be looking at a K term. And when you're graphing transformations, the correct way to do it is to work from left to right. You do all your stretching first, then we're going to do this translation, which is a horizontal shift to the left or right. And then lastly, we're going to do this. So the way that they've set up the objectives in the textbook, they broke those rules. So I'm putting it in the order you should do it. So you should always do your stretching, compressing, and then your horizontal and vertical translations. So we've covered A. We've looked at the fact that when it's negative, it opens down. When it's positive, it opens up. When that A value is greater than 1, you get a narrower graph. And when that A value is between 0 and 1, you got this wider graph. Now what we're going to do is look what happens when you add this horizontal shift or translation into your equation. So in order to do that, I'm going to introduce you to a program. So this is a program called Desmos, and it's an online graphing calculator software. So if you go to desmos.com, you can click through and just end up at this graphing calculator. And I just want to show you a series of transformations. So the first graph, and we're going to go and do these by hand after, because that's really important to be able to do. But I'm going to start with y is equal to x squared. Okay, this is my y is equal to x squared graph. Now the next one on that note is y is equal to x plus 1 all squared. So y equals x plus 1 all squared. And I want you to notice the difference. So y equals x squared is our purple graph. It's got those features. It goes over 1, up, sorry, different scale, over 1, up 1, over 2, up 4, and it does that on both sides. And what happened with the red graph? The shape is the same. You still have this vertex at 0, 0. It still goes over 1, up 1, over 2, up 4. It's got the exact same shape, except the whole graph has been shifted to the left. When you put a plus 1 in with the x, it means that you're adding 1 to x before you square it. Now, what effect does that have? Well, if we look at it from a table of values point of view, and if I look at y equals x squared, okay, so I'm going to choose values of x and I'm going to solve for y. When I plug in negative 2, y is 4. When I plug in negative 1, y is 1. When I plug in 0, 0, 1, 1, 2, 4. Now, what's going to happen when we do y is equal to x plus 1 all squared? Why is that red graph moved to the left one? And from a table of values point of view, what I want to show you is that the y values don't change. You keep this shape. From the vertex, you go over 1, up 1, over 2, up 4 in both directions. But how does that affect x? Well, in order to get this y, you're having to put a value in for x, add 1, and then square it. So if I wanted to get a y value of 4, I know that I would have to get something in the bracket that's 2, because 2 squared is 4. So I could get x is 1, or I could get negative 2. So I could put in a negative 3. So negative 3 plus 1 is negative 2. Negative 2 squared is 4. 1 plus 1 is 2. 2 squared is 4. And I can do the same thing going through. So what if I wanted to get 1? So if I wanted to get positive 1, I could put in a 0. If I wanted to get negative 1, because negative 1 squared is still 1, I could put in negative 2. If I wanted to get 0, now I have to put in negative 1. And what I want you to notice is that what happened to the x value? Every single one of these, the x value decreases by 1 in order to get the same y value. So from a table of values point of view, I had to now change x. I had to decrease x by 1 to get that same y value, to get that same shape. So if we go back to Desmos, okay, what do you think is going to happen if I do the graph of y equals x minus 2 all squared? Okay, it moved to the right. Why would that be? Well, this time you're going to decrease, you have to increase x by 2 so that when it gets decreased, you get the same value. So if we look at that from a table of values point of view, Okay, if I now look at, we'll do it below. So if I, actually, we'll just do it over here, x, y. Okay, so I know that that shape isn't going to change. I still want the 4, 1, 0, 1, 4, but this time y is equal to x minus 2 all squared. So now, again, to get 4, I have to get negative 2 squared or positive 2 squared. To get negative 2 squared, x would be 0. To get positive 2 squared, x would be 4. To get 1, well, to get negative 1, x would have to be 1. Or to get positive 1, x would have to be 3. To get 0 now, the x value would have to be 2. So what happened? Well, if you look at this, okay, to go from here to here, you had to increase all the x values by 2 in order to get that same y value. So all of these are increased by 2 to get that same y value or that same shape. So when you're looking at these, what I do is to determine it, treat it like a zero factor property. Look at this and be like, okay, so x minus 2 equals 0 when x equals 2. This one, I'll change this pen, sorry, is moved right 2. This one, there's nothing in here, so x equals 0, and that's where my vertex is going to be. This one, what makes x plus 1 equal to 0? When x equals negative 1. It's been moved left 1. Sorry, not left, negative 1, left 1. So this gives you the equation for the axis of symmetry. Okay, and if it's a minus 2, it means I had to increase my x values by 2 in order to keep the same y values. When it's plus 1, I had to actually decrease my x values by 1 in order to get the same y values. And the effect this has is that you no longer have to do a table of values in order to graph these. So if I go back to Desmos, okay, and let's do a couple more. So if I was to do y equals x plus 7 squared, all of a sudden this graph is moved left 7 because I had to decrease my x values by 7 because the equation was going to add 7 before I squared it. If I did one more, y is equal to x minus 4. Hopefully you can guess which way this is going to go. It's going to the right 4. So again, I've showed you a couple ways of thinking about this. Number one, you can think of the table of values, right? What do I have to do by x for x so that when that operation happens, I can get that same squared value? Number two, you can think of it as solving for the axis of symmetry. So taking each of these brackets, what makes x plus 1 equal to 0? X equals negative 1. So it's been moved left 1. What makes this one, x minus 2 equal to 0? When x equals 2, so it's going to be moved right 1. What makes x plus 7 equal to 0? When x equals negative 7, so it's been moved left 7. And then lastly, x equals 4 has been moved right 4. So whatever's happening to x, we say that it's opposite as it appears in my graph. So if it's a plus 1, it means you move left 1. If it's a minus 2, it means you move right 2. If it's a plus 7, you move left 7. And if it's a minus 4, you move right 4. So let's look at this in practice. Let's go back to the note. So when you look at this note, we're going to look at horizontal shifts. The first thing I want you to do is graph y equals x squared. So it starts at 0, 0, over 1, up 1, over 2, up 4, over 3, up 9. Other side, you can mirror image over the axis of symmetry, or you can do the same thing, over 1, up 1. So then we join our dots. And squeaking on the pad. So the vertex in this one is 0, 0. The axis of symmetry is the x value of the vertex, or x equals 0. Let's do the next one. The next one is a graph of y equals x plus 1 all squared. Now I know that my axis of symmetry is going to be negative 1. So what's going to happen is my vertex is going to be at negative 1, 0. Negative 1, 0. Now from the vertex, it's going to keep that same shape. If I put in an x value of 0, I'm going to get a y value of 1. If I put in an x value of 1, I'm going to get a y value of 4. If I put in an x value of 2, I'm going to get a y value of 9. So if you were to do a table of values for this, right? When I put in x is 0, 0 plus 1 is 1, 1 squared is 1. I get this same shape. So if I just know over 1, up 1, over 2, up 4, over 3, up 9, I don't have to use a table of values. The shape is not changing because there is no a value here. Okay. When we move on to the next graph, we've got y is equal to x minus 2 all squared. The axis of symmetry is going to be x equals 2, which means my vertex is at 2, 0. The graph is moving to the right 2. And again, you could check this with a table of values. When I put in 2 for x, 2 minus 2 is 0, 0 squared is 0. If I put in 3, that's over 1, I'm going to go up 1. So if I put in an x value of 3, 3 minus 2 is 1, 1 squared is 1. If I put in a x value of 4, I'm going to go up 4 because I've got that shape. Over 1, up 1, over 2, up 4, over 3, up 9. And then I'm going to mirror image that on the other side. Over 1, up 1, over 2, up 4, over 3, up 9. And I'm going to join my dots. Okay, the next one, color when I use that, there we go. Okay, the next one is y is equal to x plus 7 all squared. Again, the axis of symmetry. What makes x plus 7 equal to 0? Negative 7. That means my graph is going to start here at negative 7, 0. Same shape. Over 1, up 1. Over 2, up 4. Over 3, up 9. And again, check these points. Plug them into a table of values and you're going to get this shape. But if you can get to know the y equals x squared shape, instead of constantly having to make a table of values, you can just say, okay, where's this graph going to start? Where's my vertex? And what shape is it going to have from there? Last one, maybe pause the video, give this one a go. Okay. Again, axis of symmetry. I've got to change my color. Let's go for this one. Okay, axis of symmetry, x equals 4. So I'm going to start my graph at 4, 0. 1, 2, 3, 4. Then I can put in my table of values. I could put in x is 5, solve for y, or I can know over 1, up 1, over 2, up 4, over 3, up 9. And I can do that the other way. Over 1, up 1, over 2, up 4, over 3, up 9. And that is y equals x minus 4 all squared. Okay, so let's answer the questions at the bottom. In summary, does changing the value of h affect whether the parabola opens up or down? No, the value of a did that. Does the value of h affect the location of the vertex? Heck yes. Okay, if the equation is y equals x plus 2 all squared, that moves it left 2, and my vertex would be at negative 2, 0. If it was x minus 3, then I'd go right 3, and I would have a vertex at 3, 0. So how this looks in general, so this is how I remember it, but in general what it is that your equation is x minus h all squared. Now here's the confusing part. When h is greater than 0, so if I put an h value that's positive in here, it's going to appear negative, but it's going to go right. So if I have x minus 2, that means the h value is positive, and it goes right. If h is less than 0, it's going to go left. So if h is less than 0, it's going to be that x plus 2, right? So if I put in a negative times a negative is a positive. This is going to be your x minus 3. Okay, does the value of h change the axis of symmetry? Yes. X equals the h value. So that's that whole when you set your bracket equal to 0, x equals h. So here we put in a positive 4 value. Here we put in a negative 7 value. I like to relate it to the 0 factor property, right? We're saying what would make this equal to 0 instead of trying to figure out whether h is positive or negative. All right, so go and practice some of the ones that only have this h value now.